How many of you are playing the video game? Mobile game? Everyone. So now you are used to with that key tools. This is a software called Gasman software and been developed by millions of retrospective data by Dr. James Phillips from UK. So we are going to play the game on that. What is it? So it's been developed by this man, Dr. James Phillips. So he's having a 3 screen. First screen, you can see this screen. It's a schematic representation of patient, circuit and anesthesia machine. So if you look at this is vaporizer. Means this shows the dial concentration. Once we are delivering an agent to the machine, this is the circle. From circle, this is volume, gas is going to the tissue. So this one is alveoli. From alveoli with the proper cardiac output to the artery and to the VRG means vascular rich group. Now this one is a vascular rich group means brain, liver and kidney. Fine. Then muscle, fat and reverse flow from vein. Which factor affects the traveling of agent from circle to the machine to the circle? Which is common factor? If you increase the flow or decrease the flow. So flow is the factor. So that's the reason FGF has been kept between the dial and circle. This is FGF. What factors decides the building up the concentration in the alveoli? Alveolar ventilation or minute ventilation. Fine. If it is high, you will get the faster induction with the inhalation agent. So it's been kept between circle and lung. And from lung, if you look at this black line, alveolar black line, that suggests MAC value of agent. Sevo, it will be at 2%. ISO, it will be at 1%. And this showing black line in the vascular rich group, means the brain. So if ideally we should achieve the concentration in the brain. So this will show 2% concentration for CO as a black line, as MAC value is 2. So same way, so this is the MAC value. This part is clear to you? This is very important. What you are looking at this here? Time. So that shows the duration of anesthesia. 1 hour, 2 hour, 3 hour, 4 hour. What is this? Uptake in form of volume, vapor. Fine. So it shows the uptake means agent or gas taken up by the patient in form of vapor in liters. Okay. And this one is delivered. What we delivered. So what we deliver and what patient is taking. If you find out the difference, that is the wastage. So we can easily find the wastage from here. What wastage we are doing. And another thing, there is one tool through which you can toggle it. So from here liter to it comes to $1 or rupees.
Yeah.
So you can find out what amount you have wasted. Clear? This part clear? Then we'll go to the...
So this is basic understanding of entire system.
This is vaporizer, breathing circuit, lungs, blood, tissues, vascular rich group, muscle, fat, reversal of flow from agent, from circuit to alveoli, cardiac output, alveolar artery cardiac output. So it's showing the agent traveling path. How it works? So you can adjust the flow And apart from that, you can adjust the body, construction of the body inside the software. So what will be the muscle volume, what will be the blood volume, everything you can adjust and simulate. And you can select the circuit also. You can select the open circuit, you can select the closed circuit, you can select the semi-closed circuit. You can select the patient weight also.
An idea behind this exercise is that the way you, whatever way you are right now practicing, we'll try to simulate here.
From here.
And see how we can improve the efficiency.
Okay.
The idea is that how we can improve the efficiency.
So are you able to see this one? So he's having a 3 screen. The first screen is showing weight.
Which you can modify.
Last one, able to see the weight? काफी अच्छी आंख है.
It is visible. ठीक है ना?
So this is the circuit selected, and this the speed. 60x means we'll get 60-minute data of the patient in a 1 minute.
60 second. So 60 second in 1 second. Basically.
60 second in 1 minute. 60-minute data in 1 minute. If you keep 120x, so 120-minute data in a 1 minute. You can select the agent. So I have selected Sevoflurane, yellow. You can add the nitrous also. You can add the another agent also. So everything is possible. Now if you go to the second screen, same screen what we have discussed, it has come. And third screen, suppose you have conducted a simulation for 3 hours. So it will show the graph. Completely. FGF, deliver concentration, and circuit concentration, alveolar concentration,
developed in each tissue.
Everything. So one of you have to volunteer. First 10 minutes, what flow you are keeping and what dial you are keeping. So another important thing. This shows building up of the concentration in the alveoli. This shows the building up of concentration in the
brain.
muscular ridge group.
Brain. Basically, that's your target.
Dollar. I have converted into the rupees. So it's no doubt it's a dollar sign. But I have converted in 2018. So at that time dollar rate was 70 rupees.
No, we will have idea also. Fair idea. Okay. So anyone, like, how do you start? How do you start your anesthesia?
Sir.
Up inhalation anesthesia.
Fine, anyone.
How much flow you start? Jesse, if you are using Sevoflurane, right? So how much flow you start?
Anyone. So it's not a criticism. We know, we should know what we are doing.
For a cardiac case, usually for every case, I start with a flow of 10 liter. I oxygenate the patient.
So we'll keep a...
No, before pre-oxygenation 10 liters. Well, yes. Once I have induced the patient, I straight away come down to 1.5 liter.
Okay, just a minute. So we'll keep a 1.5. So it's a written?
Dial concentration 4%.
4%. So this is another method that we'll discuss later. 4. And for how long?
Usually, I don't see the time because I have a AGM. So once the MAC is achieved around 1.5 to 2, I come down to the dial concentration.
So with this concentration, we'll see when we are able to achieve the what end-tidal you are targeting. MAC value 2%?
2%.
Fine. So our target, as we discussed, should be 1.5. But as per his standard technique, he is maintaining up to 2. So we'll see at what time with this 1.5 liter FGF and 4% dial, we'll see when we are going to get 2% concentration in the brain, alveoli and brain. So one alveoli achieves the 2%, means this black line will stop. And another important thing, you can pause the simulation by predefining the time of pause. Like, so if you want to pause at 1 minute, 2 minutes, 3 minutes, you can bookmark it. That we'll see later. So I am running the simulation. So from here,
okay, we are starting. Okay.
So
the time
I have started 1.5 liter,
4%,
4%, 3 minutes 45 seconds. is showing the 3 minute 45 second duration. So in almost 4 minutes, we are able to reach 0.83% in the alveoli. So not achieve the target. And vascular reach go 0.38. And dollar 1.17. Now again.
Bookmark 5 minutes.
So 8.5 minutes. 8.5 minutes, we are almost reaching near 1.5 in the alveoli. So alveolar concentration is achieved. But look at this. So in a normal cardiac outpatient, once you achieve proper end-tidal, you have to wait further 3 to 4 minutes to get equilibrated with the
Brain.
and then reduce the flow. That's very important. So should I run? I am running it again.
So we'll know the exact time. Like now, tell your experience in what
Just a
time
minute.
frame
Wait,
you get
we'll,
it.
We'll check when it is.
No, not brain. At that we have achieved.
So by 11 minutes 38 seconds, we'll be able to reach the target concentration. You are monitoring through the agent monitoring. So those who do not have monitor, look at this.
So you need 10 minutes of 4% with 1.5 liter to get your target. Then what is your flow later on? Continue with 1.5 and the dial. Okay, change it to 2% Apeksh after 10
I'll
minutes.
just, what?
2%
I
कर
have
दे.
close it down.
अच्छा, close down.
Should I run it again? So we'll go through detail later. So now we'll see beauty of this software. Look, now another simulation. We'll explain the time constant with this software. So here, so what is the circuit volume? You can select the circuit volume also in this software. Look, circuit volume is 8 liter. You can change it also. And even, look, you can change the patient parameter also. Weight, alveolar ventilation. If it is restrictive lung disease, you can change the alveolar ventilation. Fixed cardiac output is you can change the cardiac output. You can change the tissue masses also. So now we are discussing the time constant with the software. So effective volume divided by effective flow, that is one time constant. Fine. So circuit volume was here 8 liter and FGF also 8 liter. So what is the time constant? 1. So at the end of one, and for a, see, it's not possible to deliver 10% CO. But for easy calculation, I have changed it to the 10. So at the end of 1 minute, what should be there in the circle? 63%. 2 time constant, 86.5. 3 time constant, 95. And a 6 time constant,
99.8.
99.8. So now, in this software, if patient is connected to the circuit, we are not going to get exact value in the circle, because from circle, patient is taking out. So what to do? So I have made the alveolar ventilation 0. Means patient is not connected. Clear? Okay, now I have made a bookmark at 1, 2, 3 and 6. Means at 1 time constant this will stop, 2 time constant this will stop, 3 time constant this will stop, and 6 time constant this will stop. Now look. What's the time there?
63. 63 point.
6.32 of 10. The percent is 63. Now, again running. 2 time constant, 86.5. And this is 2 minutes. 3 time constant, कितना होना चाहिए? 3 time constant, 95. And 6 time constant, Now we'll change it. What we'll do, we'll keep the flow 4 liter and we'll see what happens. So now CO 10%, FGF 4 and circuit volume, FGF is 8, circuit is 8. Okay? Again bookmark. So what will be the time constant?
2.
8 divided by 4, 2. So what will be the 3 time constant? 6. So at the end of 6 minutes, means 3 time constant, circle should have 95%. And 12 minutes, circle should have? Chalo, dekhte hai. This is 1 minute. 39.3. So 2 minutes is 1 time constant. आ गया? आ गया ना? Now we'll wait for a 6 minute.
ના ના થઈ ગયું આગળ.
Now this is 6 minute. 95. 3 time constant. Now we have to wait for a 12 minutes. We'll see. Ten. 12 minutes. 99.8. Done? So this is a, and you can change the circuit volume and check also. So, and this software is free to download. For education purpose, you can download this software. Is free for 1 month. And if you generate 12 mail IDs, you can use it for 1 year.
But the inhalation anesthetic which shows is only isoflurane.
Only isoflurane.
To get Sevoflurane, you need.
So for understanding
version.
purpose, for education purpose, this is very good software. So all PGs should start playing with this rather than playing with the mobile.
And unfortunately, there is no mobile app.
No mobile. Now we'll see 8 liter flow. So 70-80 kg patient. 3 percentile. We'll see when we are going to get 1.5 ERG. What time and what cost. And I have made a bookmark at 5 minutes, 6 minutes, 7 minutes, 8 minutes, 9 minutes, 10 minutes, 15 minutes, 1 hour, 1 hour, 30 minutes, 2 hours, 2 hours, 30 minutes. So we are going to continue surgery for a 2.5 hours. चलो रन करते हैं. So 1 minute, 3 minutes, 4 minutes, 5 minutes. So with 5 minutes of 8 liter, 3%, we are able to achieve end-tidal. It's 1.78, but not VRG. And so we'll further continue 6 minutes, 7 minutes. So in a 7 minute, we are able to achieve end-tidal constant, proper concentration in the brain. That is 1.56 VRG. Clear? Okay. So we'll continue with 10 minutes for easier understanding. So at the end of 10 minutes, now as discussed, we are going to reduce the flow. So we have reduced the flow to 1 liter and the dial to
Show the uptake and this
So
versus 1 liter and 4%. 1.5 and 4 versus the 8.
We'll show that. So initially, this was fixed, 4 liter, alveolar ventilation. Fine. So alveolar ventilation was 4. We have not made a change. But now, at the end of 10 minutes, it's showing 4.02. Why it is so? Automatic alveolar ventilation तो बढ़ेगा नहीं. So how it has happened? So again, this simulation was done with the 100% oxygen. I am giving the clue. Exactly. See what happens is called concentration effect. So when we anesthetize the patient, start induction with the 100% of oxygen, apart from minute ventilation and minus dead space ventilation. Because of partial pressure gradient which is generated between the alveoli oxygenation to blood oxygenation, passive diffusion of oxygen happens from alveoli to blood. That also shown by this software. Okay, how much oxygen is being additionally diffused into the blood vessel. So at the end of 3 minutes or 10 minutes, one of the PG should note down the cost of 10 minutes sevoflurane anesthesia with 8 liter 3% is 340 and uptake is 34. Who is noting down from last bench? There is a rupees. This is converted into rupees. So 340 is the cost of 10 minutes with 8 liter 3 flow and 34 ml is uptake. So 34, see what this suggests. When patient is taking up, this shows the vapor in form of the liter. At standard temperature and pressure, almost around 200 ml of vapor for easy calculation. 200 ml of vapor, ideally is 184. 200 ml of vapor equal to 1 ml liquid CO. Now, so you can see this dollar. See if I press this, what has changed here? Liter. Now it's showing the vapor in form of liter. Initially it was showing in form of the money. So 2.4 liter being utilized, vapor is utilized and only 0.25 vapor has been taken up by the body. So requirement is only 0.25 and 2.4 liter divided by 200. So 12 ml of sevoflurane has been used. VD upon VU. Last note कर लिया ना 340 and 34. Wastage is 306. 306. Should I proceed? Fine. So now we'll take another example. Now we are not using nitrous. So there will not be any second gas volume deficiency. So we can reduce the flow much earlier as Dr. Khade is doing, starting with 1.5. So 1 liter FGF, look at the dial, 8%. Dial 8% directly and 1 liter of flow, FGF. And bookmark same, we'll see. We'll see for the first 10 minutes. 3, 4, 5 minutes. Sorry. So, by 8 minutes, we are able to achieve 1.5 and above. With 8 liter of flow, 3%, it was 7 minutes. So, hardly any difference. So, high dial concentration with low flow. But if you look at the 10 minutes cost, so it's 112. आप लिख दो. So 1 liter 8%, we are able to achieve proper concentration in almost similar time frame, 7 to 8 minutes. But cost here 112 is a delivered cost and 33 uptake remains same as we discussed. 34 is uptake. What's the difference? Cost difference? So it's almost 80. And there was 306 4 times more cost. Just by changing the dial and decreasing the flow, it has made the difference. And we are able to achieve the end-tidal in almost an alveolar and brain concentrator in almost same time.
Same, absolutely same. So this is how you can change your practice, where you can start with lower flow and higher dial concentration to reduce the wastage.
But when you are using nitrous, no low flow for 10 minutes.
Yes. It is only with the air. Actually, many times it is part of Apek's lecture that nitrous, why we should not use nitrous. But most of the people are using, so we have not covered it to say that it is a crime.
So now we have reached the 10 minute with 8 liter of flow and 3% again going back. And now we are maintaining the patient with the
3%.
2.5% and 1 liter of flow. So it's a 1 liter of flow. CO dial 2.5. We have changed at 10 minute dial to 2.5 and flow to 1 liter. We'll continue about 2.5 to 3 hours. This should remain around 1.45 to 1.55 or above. 12 minutes, 30 minutes, 14 minutes, 15 minutes, 1.93. Still it is acceptable.
Fast forward arrow कर दें बाजू वाला.
No, they'll not be able to. 22 minutes, 23 minutes, 24 minutes, 25 minutes. Still it is above 1.5, 1.6. So that's called a steady state of anesthesia. We are not making any change in the dial.
So without nitrous, if you are using oxygen air, 1 liter of fresh gas flow, 8% dial, at the end of 10 minutes make it 2.5 and see how long it remains within that range. Okay.
So look, even at 37 minutes, 38 minutes, 39, 40, came down, but it will not go much lesser. Remain at
1.46, 1.47, 1.5.
So 45 minutes, 1.45.
It will come. It will come. It will show you the wastage. It is how much?
465.
465 rupees for 2.5 hours of.
No.
Achha.
45 minutes. It's up to 45 minutes.
No, let's see. It will not change much.
So 1 hour. 1 hour. Sorry, 55 minutes. We'll see for the. One hour cost is 518, and among that 340 with the high flow for first 10 minutes.
No, this was 1 liter only.
Then this was initially 8.3. I have changed it. Then I have changed the simulation. So initial 8 liter, 3% dial, 340 was the cost, and then addition of another 200 rupees.
But then we do it with 1.8 and 2.5.
This is 8.3. I will continue.
A करिए आप.
So now we'll continue further. She is remaining 1.47. Steady state of anesthesia. 1 hour. Should I make a fast forward? We can fast forward also.
Yeah, we can make.
So 1 hour 30 minutes. Cost is VRG group
1.5.
5. Now 2 hour 1.59. Fine. 2.5 hour 1.65. So steady state of anesthesia is there. And 3 hours 1.7. And look at the cost. Total cost is 944 with 1 liter. So should we go for a recovery?
Yeah, so we
last part.
Yeah, so last
So
part.
suppose
जगह देते patient को.
We'll continue with the 1 liter and shut down the vaporizer, and we'll change to the lower flow 0.5. 0.5. So we have reduced the flow to 0.5 and we have shut down the vaporizer. And what is the MAC awake value of CO? Around 0.7. So we'll see when this reaches to 0.7. Fine. So this is 3 hours. We'll check further. Cup, and once it reaches the 0.7, I will stop the simulation. Three minutes, 5 minutes, 1.53. So after shutting down, 5 minutes, no much change because of time constant.
Yeah, so if you don't increase the
7
flow,
minutes, 12, 13, 14, 15 minutes after shutting down of vaporizer, still 1.08. Now 17, 18, 19, 20, 21, 22,
so
23,
you can close the
24,
vaporizer
25.
and
So,
continue with the low flow.
0.84, even after shutting down the vaporizer, for 25 minutes, it has not reached the 0.7. We'll continue further. (30 minutes, 31, 32, 33, 36 minutes, 0.69.
आधे पेशेंट ही जागेंगे. It is still 50%.
Still 50% patient will wake up. So this is how you can play with this, and you can predict the recovery with the time constant. Now, yes, to start, another important thing. What is this? We'll go back. Now, we'll go back to 3 hours. Fine, 3 hours. 1.7 was VRG. Now you want to speed up the recovery. What is this? Flush.
No
So-
flush, but
So if I click this flush, if I click this flush,
basically it will wash out this circuit. Zero.
so it's showing the 30 liter. So this software also shows that also. So now you run it, your recovery will be faster. See.
Because gradient will be higher in the circuit.
And if I increase the flow along with that, so look at this. 6 minutes, patient is out. Fine. So that's about the software. You can download the software with single ID, mail ID. Use it for 1 month. You'll get the complete idea. And what is this? What is this? It's not intravenous. So many injection of the vapor that happens with the juice or ACs.
So there is something
So it
called
also shows
DIVA
if you
type of
directly inject
vaporizer.
the inhalation agent into the circuit, what happens to the patient, you'll also get to know with this software.
So DIVA type of vaporizer, which is right now available with juice and I think McVet machines. DIVA vaporizer, direct injection of volatile anaesthetic agent. That's a DIVA full form. So that can also be simulated here.